Hey, it's Plumber Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. Hello, and welcome to this presentation of the International Fuel Gas Code. My name is Thomas, and in this presentation we're picking up where we left off as we're looking at section 402 and examining gas pipe sizing. We've looked at 402, all the sections in there in a previous presentation. We looked at commercial gas pipe sizing with the longest length method. And now we're ready to look at another method, which is called the branch length method. So let's see what we can learn. All right, in this presentation, as we examine the branch length method, I'm assuming that you already understand the longest length method, that you've paid attention, that you've watched those presentations, and that you understand that. You'll need that understanding because the branch length method is a variation of that. Let's get into it. Let's go to section 402.4.2. This is what gives us the explanation of the branch length method. Here is what you need to understand about the difference. It is very much like the longest length method, but it is a variation on that. So as we size this, you'll see this, it's similar. The process is similar, but there are some key differences. One thing you also need to understand about the branch length method is that it is less conservative. There's less headroom. What that means is as you're sizing, you're more likely to undersize if you're using the branch length method. If you want to stay far away from undersizing, then stick with the longest length method. But why would it be important to use the branch length method? If you're trying to save on material costs, this might help because you can dial it in a little closer on the branches and perhaps save some material by not oversizing. So there's kind of a balance there, and you have to decide which one to use. Branch lengths in the branch length method are measured from the point of delivery to the end of each branch. Now, in the longest length method, we go from point of delivery to the furthest appliance. In this case, we go to each appliance, and it's measured from the point of delivery to that appliance. Because of this, we use different rows. When we're using the longest length method, we stay on the same row. We find our longest distance and stay on that row the whole time. That's more conservative. But in this case, we're going to be bouncing around on that sizing table a little bit, depending on the length from the point of delivery to the branch, to whatever appliance we're going to. And that's what creates some variation here. Quick review, we're going to use the same 6 steps with a little variation, of course. Step 1, when we're using the branch length method, is to find the maximum BTU per hour, just like we did before. From all appliances, we'll find the pipe section lengths and the length for each of the branches, rather than just the longest length. We will calculate for the cubic feet per hour for each section and branch, find the correct sizing table, and then use the tables to size each section and branch. We're going to look at 2 examples of the branch length method. We'll size out the whole system. By then you should have a really good idea of how this works. Here is the diagram that we're going to be going off on example 1. Let's have a close look at this. Starting with the point of delivery, we have the meter, and this is a residential plan, so we're going to see a variety of appliances branching off from this. Let me explain how this system works. We have a steel pipe for the trunk line, schedule 40, and that's going to run all the way out. From that steel pipe, we have branching off some CSST going to each of the appliances. And that is going to affect our sizing because we'll be using different tables for this. Let's have a quick look at the different appliances that are connected. We have a range at 60,000 BTUs, a dryer at 35,000 BTUs. We have a water heater at 40,000 BTUs. We have a furnace at 75,000 BTUs. And we have a gas grill at 20,000 BTUs. On this diagram, we have all of our sections labeled A through J. We also have our pipe length distances. That's going to help us as we're figuring out the length for each branch. Other important system information on this one, we have a pressure coming in at 9-inch water column using natural gas with specific gravity 0.60. Again, the trunk line is Schedule 40 steel, and all the branches are CSST. Let's jump into it. Step 1, find the maximum BTU for all appliances. We've looked that over. We know the range is 60,000 BTUs. We know the dryer is 35,000. We know the water heater is 40,000. The furnace is 75,000, and the gas grill is 20,000. Moving on to the next step, we're going to find our sections of pipe. Now, A, B, C, D, and E, those are all the steel pipe, and we're going to call those our sections with the branches coming off. We're going to size each of those sections separately because they each carry a different amount of BTUs. Then we also have our branches, which are F, G, H, I, and J, and we'll be sizing each of those separately. Step 3 is to find the developed length for all of those sections and branches. As we look at this, we do have the longest run from the meter to the gas grill. That is going to be what we use for our trunk line, for our main sections. So if we add those up, A is 10 feet, B is 10 feet, C is 25 feet, D is 15 feet, E is 5 feet, and then we're going to follow F out to the appliance, and that's 20 feet. The total for all of those is 85 feet. Look at these tables. I've split this up between the steel and the CSST. On the steel side, where all of those are our trunk line, we're going to keep the same developed length for all of those. We're using the longest length. So we've got 85 on all of those. The difference with this branch length method is that we are going to do each branch separately, and we're going to get different lengths for those. So as we look at our gas grill, that's F. That one is the same as our longest length, the one that we've been using, so 85 feet. Let's consider the range. As we look at the range, it's the closest to the source, to our point of delivery. So we have A at 10 feet, and then we follow G with 15 feet. 10 plus 15 is 25 feet, so we have 25 feet for G. Let's look at H for the dryer. What are we adding up there? The dryer branches off down towards the bottom there. We have 10 feet for A, 10 feet for B, and 20 feet for H. And so we have 40 feet for the dryer. What about the water heater? I. Water heater's up there towards the top. We have A is 10 feet, B is 10 feet, C is 25 feet. That brings us 45 feet to that point where it branches off. We're going to add 15 feet for the CSST that goes to the water heater. That's going to give us a total of 60 feet. We have 60 feet for the water heater. The furnace for J, follow the trunk line. We've got A has 10 feet, B has 10 feet, C has 25 feet, and D has 15 feet. That's going to get us to 60. And then we're going to follow that CSST from J up to the furnace with another 15 feet. That's going to give us a total of 75 feet. 75 feet for the furnace. Now, hopefully you can see how this works as we're finding our lengths for each of the branches. We can move on to step 4, which is to calculate the cubic feet per hour for each section and branch. Let's divide those up again. The sections that we have are that main trunk line. We've got the steel pipe, A through E. Let's examine how many BTUs they have. We have on section A the total load for the whole building. If we examine all of the BTUs for this system and add those up, we're going to come up with 230,000 BTUs. We'll divide by our BTU per cubic foot, which we're going to say we're at sea level. So we're going to keep this simple and divide by 1,000. And that's going to give us 230 cubic feet per hour. Look at section B. Section B continues on after the range, so we subtract 60,000 BTUs off of our total. That's going to leave us with 170,000 BTUs divided by 1,000. That gives us 170 cubic feet per hour. Let's examine section C. The total BTUs for those appliances is 135,000 BTUs. We divide by that 1,000 and we get 135 cubic feet per hour. Moving on to section D. Section D has the furnace and the gas grill together. Combined total BTUs for that is 95,000. We divide by 1,000 and we get 95 cubic feet per hour. And finally, with steel pipe E, on that section, it's a little piece of steel pipe that's leading to the gas grill. It's 20,000 BTUs. We divide by 1,000 and we get 20 cubic feet per hour. We've got this completed on this section. Now we have all of the trunk line cubic feet per hour figured out. That's what we need in order to size. Let's have a look at the appliances themselves. This is where we have our branches listed for each of those. F is the gas grill and has 20,000 BTUs. We divide by our BTU per cubic foot of 1,000 and we get 20 cubic feet per hour. The range, G, 60,000 BTUs, divide by 1,000 and we get 60 cubic feet per hour. The dryer, H, has 35,000 BTUs, divide by 1,000 and we get 35 cubic feet per hour. The water heater, I, 40,000 BTUs, divided by 1,000 and we get 40 cubic feet per hour. And finally, the furnace, J, 75,000 BTUs, divided by 1,000 and we get 75 cubic feet per hour.
Okay, but when are we actually gonna size some pipe?
First, we have to select the correct sizing tables. Now, here's where we run into an issue because we have steel pipe running as the main trunk. We have CSST running as all the branches, and you cannot look on the same table for both of those. We're going to be looking at separate tables. So for the steel trunk line, we're going to look at table 402.4, parentheses 2, and this gives us our Schedule 40 metallic pipe. We verify that it matches our gas pressures and those requirements. Now we know we've got the right table for the steel. For the CSST, we're going to flip a few pages till we find the corrugated stainless steel tubing tables. We're going to match the right pressures, including the type of gas and pressures. And this is table 402.4, number 15. This is the table we're going to be using. Now, I want you to look at this table and look at the sizes across the top. The tube sizes are not in inches. They have the EHD. Now, that might be very confusing to you. So let me explain. EHD stands for equivalent hydraulic diameter. This is the way that CSST tubing is sized by the EHD. For comparison, let's look at inch sizes and compare that to the approximate EHD. Now, I say approximate because manufacturers may vary a little bit, and you want to make sure with CSST, whatever manufacturer you're using, that you know what size you should have, okay? But here we go. 3/8 would be comparable to 15 EHD. If we're looking at half-inch pipe, that's 18 and 19. 3/4, 23 to 25. 1 inch, 30 to 31. 1 1/4, 37 to 39. 1 1/2, 46 to 48. And 2 inch, we've got 60 to 62. Now again, this is not exact. These are approximates. Make sure you understand what you're dealing with as you're installing, but this is close.
Okay, on the tables, man. Let's size some pipe.
We are now ready to size this thing. We've worked pretty hard to get to this point. Starting with section A, the total load for everything. As we look at our table, it has 230 cubic feet per hour, and we are using 85 feet for the developed length. We're going to go to our table, come down to 85. Because it's more than 80, we have to go to the line that is 90. And we'll be using this line for all of our trunk line sizing. We're looking at row 90 and we have 230 cubic feet per hour. That's more than 52. That's more than 110. That's more than 207, but it's less than 424. So we'll stay in this column. We'll go to the top and find 1¼ inch pipe. We can put that on the table. Let's look at section B. We still have 85 feet. We're using that for the trunk line. Notice on section B that we have dropped off the range. There's 170 cubic feet per hour. Let's take that to the table. We'll go down to line 90 on our length. Coming across with 170, it's more than 52. More than 110, it's less than 207. So we'll stay in that column, move to the top, and we find that we have 1-inch pipe. We can put that on the table. Pipe section C, we're still using 85 feet. This has 135 cubic feet per hour. Section C is in that middle. We've dropped off the range and the dryer. We'll go to line 90. It's 135. That's more than 52, more than 110, but it's less than 207. So we'll go to the top, and we're going to stay with 1-inch pipe. We'll put that on our table. Let's go to section D. Section D, using the same length, we have 95 cubic feet per hour. Section D is catching the furnace and the gas grill. We take that 95 cubic feet per hour to our row 90 for our developed length. 95 is more than 52. It's less than 110. We can stay in that column, go to the top, and we find 3/4-inch pipe. We'll put that on the table. Let's look at the last little section on our trunk line. Steel pipe, 85 feet. We're dealing with just the gas grill at 20 cubic feet per hour. It comes right off the end there. On row 90, we've got 20 cubic feet per hour. That's less than 52. We'll stay in the first column, go right to the top, and we have 1/2-inch pipe. We will put that on our table. Hey, check it out. We've completed the steel pipe section of this system. Now that we have sized out the trunk line, all the steel pipe sections are figured out, let's go back and figure out our branches, the CSST. This is where the branch length method comes into play, because every one of these branches has a different length and we'll be using a different row on the sizing table. The first one, gas grill F, has the same developed length as all the others we dealt with on the trunk. It's the furthest distance, and it has a total cubic feet per hour of 20. So we'll stick with that line 90, but this time we're using a CSST table. So we're going to go into this with 20 cubic feet per hour on row 90. That's more than 10, that's more than 14. It's less than 28. So we come to the top and we find that the tubing size is 18. We'll put that on our table. Let's go to the range. The range is very close to the point of delivery, only 25 feet, with 60 cubic feet per hour. If we go to the table then, we have 25 feet. We can follow that down. There is actually a line on this table for 25 feet. We'll go on that line, and remember we have 60 cubic feet per hour. That's more than 19, more than 27, more than 52. We do have one that's actually 60. If we move to the top from there, we'll find that the tubing size is 19. Let's put that on our table. The dryer, branch H, is 40 feet from the point of delivery. We'll use that for our distance. And the dryer has 35,000 BTUs with 35 cubic feet per hour. We'll go to line 40 on the distance. Coming across with 35, it's more than 15, more than 21. It's less than 41. So we can stay in that column, come to the top, and we find that the tubing size is 18. We'll put that on our table. The water heater is 60 feet from the point of delivery, 40,000 BTUs with 40 cubic feet per hour. We'll follow our distances down to line 60, coming across with 40 cubic feet per hour. It's more than 12, more than 17, more than 34. It's more than 38. It's less than 68. We'll go in this column, follow that up to the top, and the tubing size is 23. We'll put that on our table. Finally, we have the furnace J. This one is 75 feet from the point of delivery, 75,000 BTUs and 75 cubic feet per hour. We'll come down and look for our line. There's no 75, so we'll have to go to 80. We're on 80 feet developed length. We come across with 75. We'll jump over there. It's more than 60, more than 69. It's less than 113. So our tubing size as we come to the top is 30. And we'll put that on our table. Now we have the correct tubing size for each branch, sized specifically for that branch. And in this situation, you'll notice that because we did that, we probably have some slightly smaller tubing sizes, which may be really to our advantage as we're running these, rather than having them oversized running to each of the appliances. All right, let's finish this thing off. Did you learn something from this? Do you understand now the difference between longest length method and the branch length method? You see that most of the steps are the same in the sizing process. The big difference being that we jump around a little bit as we size each branch on that sizing table, depending on the distance. Once again, this is not as conservative. It does not leave you headroom, not room for error. You've got to be accurate, but if you are, you might be able to save a little on pipe size. Maybe that saves a little material, a more accurate way to figure this out. Ultimately, it's not as simple as the longest length method, so that's why we use longest length method all the time. It's just really basic. But now you know the difference. Make sure you check out the next video to solidify your understanding of the branch length method. I'll see you there.